Let's continue graphing rational functions. We'll do the following example. Sketch the graph of 2x squared minus 8 over x plus 1. All right, so in order to do this, we're going to need to factor it first. So let's factor out the top and the bottom. So we've got f of x, let's a little more space here. F of x is 2x squared minus 8 over x plus 1. Again, I always recommend writing down the problem again or writing down the formula again just to make sure that you've got it right. Then let's factor out 2 from the top. We've got 2x squared minus 1 over x plus 1. And we know we can factor x squared minus 1 into x plus 1, x minus 1. Right? Now, before we cancel the top and bottom, let's remember to list off our wholes. And since we have this factor on the top and bottom, we have x equals -1 is a whole because that makes both of these factors 0. And so we've got sort of multiplying and dividing by 0 when x equals -1. We can't divide by 0, so that's a whole. Next, we're going to have a 0. And where's the 0? That's going to be at x equals 1. All right. So we know there's a 0 at x equals 1. We know there's a whole at x equals -1. But we also have, if you notice, degree of the top is equal to 2, and the degree of the bottom is equal to 1. And the degree is this exponent here. This exponent is 2. Okay? So that means we've got a horizontal, a slant or oblique asymptote. And when we have a slant asymptote, what we want to do is long division. So let's find our slant asymptote. And this is because this degree is 1 more than that degree. The numerator has a degree 1 more than the denominator. So to find the slant asymptote, we're going to go back to the original numerator and just do long division. So the original numerator is 2x squared plus 0x minus 8, and the denominator is still x plus 1. So how many times does x go into 2x squared? It goes in there 2x times. So we have 2x squared plus 2x. Subtract, we have 2x squared minus 2x squared is nothing. Then we have 0x minus 2x gives us -2x. We bring down the minus 8. How many times does x go into -2x? Well, it goes in there -2 times. So multiply this by -2, we get -2x minus 2. And when we subtract these, -2x minus a -2x is nothing. But then we've got -8 minus a -2, and that gives us a remainder of -6. Now the remainder doesn't really matter while we're trying to graph this slant asymptote, but what this basically says is we're going to have the line y equals 2x minus 2 as our slant asymptote. In this case, we just have that line and a whole because we notice that the 0 of this line is exactly at x equals 1. So this one is not so bad to graph. We've got, I'm going to redo that. Wow, I'm just batting 1,000 on these things. There we go. We've got a 0 at x equals 1. And we're going to have a whole at x equals -1, so let's remember that. And this line is basically going to be, it's got a slope of 2. So it's going to go up 2 over 1. So up 2 over 1, so it's going to go through this point. Up 2 over 1, it's going to go through this point. We also notice so this is y equals 2x minus 2. That's what I'm graphing here. It's got a y-intercept at -2, and that's in line with what we've got. So try again. That's close enough. So we've got this until we get to x equals -1. And when x equals -1, we've got a whole. And then, oops, I forgot to lift the pencil up. And so this is the graph of our function. It's essentially the line y equals 2x minus 2, because that's what happens when we factor out the x plus 1 from top and bottom. But we've got this whole right here, which indicates that this function is not defined when x equals -1. Let's do one more example. So let's sketch how about f of x equals, and I'll just factor this one out for us. Let's do x plus 1 times x minus 1 over x minus 3, x minus 2, and x plus 2. Okay, this one's going to take a little bit of effort. It's got 5 factors. None of them cancel out. So solution, let's look for our zeros. Well, zeros are going to be, well, first off, holes. We have no holes because there are no shared factors on the top and bottom, right? So we've got no holes. We've got zeros at x equals plus or minus 1. And we've got vertical asymptotes at x equals positive 3, positive 2, and negative 2. Now what we need to do is set up all of our different ranges. Those are the ranges around these points, and then do our sign chart. So those ranges are going to be, so sign chart, those ranges are going to be negative infinity up to the leftmost value is going to be negative 2, then from negative 2 to negative 1, then from negative 1 to positive 1, and then from 1 to 2, from 2 to 3, and finally from 3 to infinity. This is a lot of ranges here. And we've got, how many factors do we have? We've got the factor, and I'm just going to do them again from left to right. We've got the factor x minus 2. Yeah, x plus 2. We've got the factor x plus 1. We've got the factor x minus 1, factor x minus 2, and the factor x minus 3. Notice that as I'm making the sign chart, it doesn't really bother me if these factors are in the denominator or the numerator, right? All I care about is that they are factors somewhere in my rational function. And then here we'll have the total. So because I've lined these up so nicely and they're all degree 1 factors, what we're going to get is x plus 2 is negative initially, but then once it turns positive, it stays positive. We have x plus 1 is negative here and here, but then it's going to be positive for the rest of these. And you'll notice this nice little pattern, and I know I'm going quickly, but you can pause the video and check that this works. Because I've lined up my linear factors in order, I have this nice chart. And now I've got an odd number of negative signs, even number of negative signs, odd number, even number, odd number, and no negative signs. So this is my total behavior of my graph. Okay, so now what I can do, I'm going to make a little mark in here for 0. Now I can just treat this, cheat again, treat this as my real number line, and I just list off, well, the zeros are at plus and minus 1, so here's negative 1, there's a 0, positive 1, there's a 0, okay, that's fine. So here's negative 1, here's positive 1. Then I've got something happening at positive 2. What's happening at positive 2? I've got a vertical asymptote. So I'm going to list that that happens at positive 2. Then I've got a vertical asymptote at positive 3. This is happening at 3. And I've got something else happening here at negative 2. What happens at negative 2? I've got a vertical asymptote. We see up here it's a vertical asymptote. So now I know when this thing is positive and negative. So it starts out negative, which means I'm going to be coming in from, oh, I've left out one thing. Where's our horizontal asymptote? Or what's the horizontal asymptote theorem say? Let's go back to the hat. Horizontal asymptote theorem tells us that if the degree of the numerator is less than the degree of the denominator, then we have y equals 0 as our horizontal asymptote. And that's where we are here. The degree of the numerator is 2, degree of the denominator is 3. So we've got a horizontal asymptote at at y equals 0. I should have mentioned that earlier. Luckily, I can just cheat because I can just move all this stuff down and we can forget about the fact that I made a mistake. We say the horizontal asymptote theorem tells us the degree of the numerator is strictly less than the degree of the denominator, which implies horizontal asymptote at y equals 0. So I've also got this horizontal asymptote at y equals 0 here. Now, since I'm starting negative, it's going to be following that horizontal asymptote until it comes and gets close to -2, at which point it follows the vertical asymptote. Then we're at positive in the next interval, so we're coming down that vertical asymptote, and then we have to hit 0. Because we're switching from positive to negative, that means we're crossing the x-axis. Also, we know that we're going to change signs because the multiplicity of this 0 is odd. And then we've got to hit the 0 again here. Again, we go from negative to positive. Well, that's going to be crossing the x-axis. And we could have guessed that because, again, the multiplicity of this 0 here is 1. There's no exponent, so this is like an exponent 1 here on that factor. And actually, the multiplicity of these vertical asymptotes are all odd, which means we're going to be changing. You see that it goes minus, plus, minus, plus, minus, plus. We're changing sign every time we go from one interval to the next. So we can just keep changing sign like this. And this is our nice sketched graph. Hope that made some sense. And feel free to pause it, go back, rewatch it. You might need to review sign charts. You might need to review the horizontal asymptote theorem. But this is, I think, about as big and nasty of an example as I can give you for